Okay, so now let's do a couple of examples here. So let's say that you have, let's say that a mother tells his daughter, the mother, let's call the mother tells his daughter, 7 years ago, I was 7 times as old as you were then. I was seven times as old as you were then. Okay, and 3 years from now, I will be 3 times as old as you will be. I will be 3 times as old as you will be. Now you want to find the mother's age and the daughter's age, basically. So I'm going to take the mother's age. I'm going to take the mother's age as for example X, and the daughter's age I'm going to take as Y. And remember that this is their current age, not their age, for example, 7 years ago, or 6 years ago, or 3 years ago, or anything like that. And this is also the current age of the daughter. Okay, so now the mother says that 7 years ago I was 7 times as old as you were then. So 7 years ago, if the current age of the mother right now is X, 7 years ago she was X minus 7 years old, right? And she's saying that she was 7 times as old as you were then. So 7 years ago the daughter was Y minus 7 years old, and then the mother was 7 times as old as the daughter. So 7 times Y minus 7. And so you can simplify this a little bit. X minus 7 is equal to 7Y minus 49, and then for example 7y is equal to X plus 49 minus 7. 7y is equal to plus 49 plus X minus 7, and so 7y is equal to X plus 42, and so y is equal to divide by 7, y is equal to 1/7 X plus 42 divided by 7 is equal to 6. So that is one of your equations. And then the next statement that we had was 3 years from now I will be 3 times as old as you will be. So 3 years from now is basically right now the mother is X years old, and 3 years from now she's going to be X plus 3 years old, and 3 years from now she'll be 3 times as old as the daughter is going to be. So the daughter 3 years from now is going to be Y plus 3 years old, and then 3 times that would be this. So X plus 3 is equal to 3y plus 9, and then 3y is equal to x, and then 3 minus 9 would be negative 6, so y would be equal to 1/3 x minus 2. So that's basically another equation that you have. So now, first of all, if you write these equations in let me call this 1, for example, and call this 2, and I want to open my window as well. Okay, so you have these two equations over here, and if I write them as y is equal to 1/7 x plus 6 and y is equal to 1/3 x minus 2, and if I want to write them in general form, it's going to be 1/7 x minus y plus 6 is equal to 0. Minus y plus 6 is equal to 0, and this one is going to be 1/3 x minus y minus 2 is equal to 0. Okay, and then if you basically, you can see that a1 to a2 is 1/7 to 1/3, which is equal to 1/7 times 3, which is equal to 3/7. And b1 to b2 is equal to -1 to -1, which is equal to 1. And c1 to c2 is equal to 6 to -2, which is equal to -3. So you see that basically a1 to a2 is not equal to b1 to b2. That means that you will have one unique solution. One unique solution, meaning that you will have two intersecting lines. And what that also means is that this pair of linear equations is consistent. Okay, so now let's go and do the graph of this function as these two equations as well. So let's say that you have y is equal to 1/7 x plus 6 and also y is equal to 1/3 x minus 2. So if I take this as 1 and take this as 2, then you see that over here, if I draw a 2D plane like this, I will have basically in 1 you will have you have a y-intercept of 6, so basically 1, 2, 3, 4, 5, and 6. This is 1 point, and your slope is 1/7. That means that for 7 units of horizontal change, you have 1 unit of vertical change. So you have 1, 2, 3, 4, 5, 6, and 7. So that means that 7 units would take you over here, and then 1 unit of vertical change would get you somewhere over here. And so this is basically the line that you have over here. So this is 1, 2, 3, 4, 5, 6. So you have 1, 2, 3, 4, 5, 6, and 7. So this point over here is 7, 7. And this is 0, 6. This point over here. And then the other line that you have is, so this is number 1 Number 2 is your y-intercept is -2, so you have this point over here, and then 1/3 x is for 3 units of horizontal change, you have 1 unit of vertical change. So that would get you 1, 2, and 3, and 1 unit, so that would get you somewhere over here. And the two lines are going to meet somewhere over here. I would say, I don't know, if this is 7, so 1, 2, 3, 4, 5, 6, around 2.5, so 12, around 18 comma, I don't know, 18 comma somewhere over 18 comma 10 or something like that is going to be your answer. I do not exactly know, because you have to just keep going in this direction and see what happens. And of course our graph is not that great, so you can have some sort of one. Somewhere over here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 comma this thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. Somewhere around 18 comma 10 or so. So this is your graph. Okay, not very accurate, but that it should look like this. And also, if you want to solve the problem, actually what you can do is that well, what you can do is that you can write your equations as y is equal to 1/7 x plus 6, and also y is equal to 1/3 x minus 2. Okay, and then express one of these as in terms of, express y in terms of x, or express x in terms of y, or something like that. So for example, if you take this as 1 and if you take this as 2, you see over here y has already been expressed in terms of x. So I can take 2 now, and instead of y I can write 1/7 x plus 6. 1/7 x plus 6, and that's equal to 1/3 x minus 2. 1/3 x minus 2. Okay, and take this to the other side, so 1/7 x is 1/7 minus 1/3 x is equal to -2 -6, and that's the same thing as x times 1/7 minus 1/3 is equal to -8, and then 1/7 minus 1/3 is equal to 21. 3 minus 7 is equal to -4/21. So negative x times -4/21 is equal to -8. So x is equal to -8 over -4/21, which is equal to, these two will cancel out, 8 times 21 by 4. So 2 times 21 is equal to 42. 42. So x is equal to 42. Okay. Now if x is equal to 42, then you can take any of these equations over here. For example, you can take 1, for example, and write y is equal to 1/7 x plus 6, and then you know that your x is equal to 42, so y is equal to 1/7 times 42 plus 6, and that's equal to 6 plus 6 is equal to 12. So y is equal to 12. That means that the mother's current age is 42, and the daughter's current age is 12. Okay, so x is equal to 42, and that's equal to 12, if I'm not mistaken. Yes. And so what that means is that, now let's check the answers here. It says that 3 years from now I'll be 3 times as old as you will be. So 3 years from now, the mother is going to be 45 and the daughter is going to be 15, and 3 times 15 is equal to 45. This is okay. And 7 years ago I was 7 times as old as you were then. So 7 years ago the mother was 35 and the daughter was 5. 7 times 5 is equal to 35, which is actually correct. Okay. So that's basically how you solve these kinds of problems. I cannot really go over each and every problem here, but I will do a couple of them, probably 4 or 5 of them, to see. Do at least a couple of them, and then we will get to the next things over here. Okay, so as another example, let's say that you have a number of students who took part in a quiz, for example. Then basically you know that the total number of students who basically took part in the quiz was 10 people. So the total number of students was basically 10. And if the number of girls is 4 more than the number of boys, the number of girls was 4 more than the number of boys. The number of boys. Find the number of boys and girls who took part in the quiz. We want to find out the number of girls and boys. So if I take the number of girls, as x and the number of boys as y, then I can say that the total number of these students, or girls and boys together, was 10. So I can say that x plus y is equal to 10. And also I know that the number of girls, which is basically x, was equal to 4 more than the number of boys. So that means the number of boys plus 4. So y plus 4. So basically now that I have these two equations, I can somehow solve them and find out what x and y is. But before you do that, you can actually you can probably also do the graph, meaning that you can write this as y is equal to negative x plus 10, and here you can write y is equal to x minus 4. So for example, here you can see that I guess I need to do these graphs on a different it's okay for now, let it be. So let's say that your y-intercept was equal to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so this is one point on the graph of this equation, and your slope is negative 1. So negative 1 is the same thing as negative 1 by 1. And that means that for every horizontal change you have 1 unit of vertical change, but negative. So that means that if you change horizontally by 1 unit, you have to change vertically by 1 unit, but you have to fall because this number is negative. So you end up over here, and then you will have a line like this. Okay, so this is y is equal to negative x plus 10, and you can see that lines with a negative slope are basically, this is a positive slope and this is a negative slope. Okay, and this over here, this line over here has a slope. If the line is completely horizontal, here the slope is 0, and if the line is completely vertical like this, then the slope here is not defined, because you would be because you're not changing your x, but you're changing your y. So basically your slope is basically defined as change in y, or basically vertical change over the change in x, which is basically the same thing as horizontal change. So here basically your horizontal change is actually when you have a line like this, your horizontal change is actually 0. You're not going anywhere from this point. So this part over here is 0, and then your y is changing. So you're dividing by 0, so dividing by 0 is not defined in mathematics. So you say that a vertical line, the slope of a vertical line is not defined. So basically you get 4 different types of slopes: positive slope that looks something like this, negative slopes that look something like this. The line is, as you can see, as you move towards the right, your y's are decreasing and decreasing and decreasing. That's a negative slope. This is slope 0, meaning as you are moving towards the right, your y's are not changing. They're remaining constant. So this is slope 0, and this is slope not defined. Okay, so that's basically that. So this is one of your lines. The other line that you have is y-intercept is -4. So -4 would be 1, 2, 3, and 4, and your slope is 1, meaning 1 over 1. That means for 1 unit of horizontal change, you have 1 unit of vertical change. So if the reference point is over here, you have 1 unit of horizontal change, 1 unit of vertical change. So you would have a line like this. Of course, I'm going to draw these lines somewhere over here, and it's somewhere like 1, 2, 3, 4, 5. I don't know, probably 5.5, comma 3, or 5, comma 3, or something like that. Not accurate, but something like that. Now, if you basically draw if you were to actually solve this problem algebraically, you know that x plus y was equal to 10, and x was equal to y plus 4. So I can take this, for example, I can call this 1, I can call this 2, I can take 1, and for example, I don't know, you can express x in terms of y, for example. So you can write this equation as x is equal to 10 minus y. And then you can take 2 and substitute 1 in 2. So then x would be equal to 10 minus y is equal to y plus 4. And you see it's giving you this solution, which means that actually it's not supposed to be like that. Let me see. If you have x plus y is equal to 10 and x is equal to y plus 4, x plus y is equal to 10, so x is equal to 10 minus y. 10 minus y. So then 10 minus y is equal to y plus 4. That actually doesn't make any sense. Let me see if I can find the answer over here. I think I have made a mistake, because these two equations have actually do have a unique solution. So let me see, x plus y is equal to 10, so x is equal to 10 minus y. And then over here, x is equal to 10 minus y is equal to y plus 4. Oh, okay, right. So here you can write negative y and take this y to the other side. Negative y is equal to 4 minus 10, and negative 2y is equal to negative 6. So y is equal to negative 6 by negative 2, which is equal to 3. So that means that the number of boys was actually 3. Now that you know the number of boys here, you can use any of these equations. For example, x plus y is equal to 10, and you know that your y is equal to 3, so x plus 3 is equal to 10, so x is equal to 7. So the number of girls was then you had 7 girls and 3 boys over there. So that's another thing over here. Let's do another example here, and there is a ton of these examples that you can do, but the important thing is that you basically write your equations algebraically right, and then of course you can solve them. There is nothing really complicated about them. And then you have okay, so we have a couple of good questions over here. For example, we have a couple of linear, basically pairs of linear equations, and you want to basically compare the coefficients. So let's say that you have, for example, 5x minus 4y, 5x minus 4y plus 8 is equal to 0, and then you have 7x plus 6y minus 9 is equal to 0. Okay, so you want to compare these. So basically A1 to A2 is equal to 5 to 7, the coefficients of x. B1 to B2 is equal to negative 4 to 6, and C1 to C2 is equal to 8 to negative 9. So you see that basically A1 to A2 is not equal to B1 to B2, right? So that means that you have intersecting lines. You have intersecting lines, and you have one unique solution. Okay. Or let's say that and of course that means that the lines are not parallel or are not coincident. They're actually intersecting lines like this. Or let's say that you have 9x plus 3y plus 12 is equal to 0, and you have 18x plus 6y plus 24 is equal to 0, and then you see times 2 times 2. You see over here, if you multiply this equation, if you take this whole equation and multiply it by 2, you will get 2 basically. So if you take 1 and multiply it by 2, that will give you basically 2 times 9x plus 3y plus 12 is equal to 0. If you multiply 2 by every term in here, you'll get 18x plus 6y plus 24 is equal to 0. Which is, I'm sorry, this is y. Which is exactly what you see over here. So that means that these two lines are actually equivalent lines. That means that they are going to be basically coincident, meaning that you would get basically one single line, and both of these lines will be represented by basically one single graph, something like this. Both of the lines are going to be the same line. And if you take for example, A1 to A2 here, that's 9 to 18, which is equal to 1 to 2. B1 to B2 is going to be equal to 3 to 6, which is equal to 1 to 2, and C1 to C2 is equal to 12 to 24, which is equal to 1 to 2. So as you can see, A1 to A2 is equal to B1 to B2 is equal to C1 to C2, and that's basically why the lines are coincident lines. And you have infinitely many common solutions. Okay, so I think it's enough about these. Now let's do a couple of these and compare them based on the basis of being consistent or inconsistent. So let's say that you have, for example, 3x plus 2y. 3x plus 2y is equal to 5, and 2x minus 3y is equal to 7. Okay, and as we agreed before, you don't really have to take these to the other side of the equation, because when you take them to the other side, both of them will be then negative, and then when you take the ratio, you're going to get the same number. So you don't have to take these to the other side of the equation. So now basically, if you take A1 to A2, that's going to be 3 to 2, and if you take B1 to B2, that's going to be 2 to negative 3, and C1 to C2 is going to be 5 to 7. Okay, so you see that basically A1 to A2 is not equal to B1 to B2, and what that means is that you are going to have a pair of intersecting lines. a pair of intersecting lines, and what that means is that you have one unique solution. One unique solution, and so of course the pair of basically linear equations is going to be a consistent pair of linear equations, because you have a solution. It's going to be consistent. Another example that we could do is 2x minus 3y. 2x minus 3y is equal to 8, and 4x minus 6y is equal to 9. And so if you take basically a1 to a2 here, is going to be equal to 2 to 4, which is equal to 1 to 2. b1 to b2 is equal to negative 3 to negative 6, which is equal to 1 to 2, and c1 to c2 is equal to 8 to 9. So here you can see that a1 to a2 is equal to b1 to b2, which means that you get basically a pair of intersecting lines, which means one unique solution, which means that the pair is consistent. Okay, now let's do something which is inconsistent, hopefully if you can find one. So let's say that you have 5x minus 3y. 5x minus 3y is equal to 11, and negative 10x plus 6y is equal to negative 22. So here a1 to a2 is equal to 5 to negative 10, which is equal to negative 1 to 2. b1 to b2 is equal to negative 3 to 6, which is equal to negative 1 by 2. And c1 to c2 is equal to 11 to negative 22, which is equal to 1 to negative 1 to 2. So you see that a1 to a2 is equal to b1 to b2, which is equal to c1 to c2, which means that you have coincident lines, and so basically you have infinitely many solutions, which means that it's still consistent. Okay, now let's do another one here. Let's say that you have, oops, I have to, I can't, okay. Okay, so I need to probably do a couple of screenshots and then probably close this. So let's see. Okay, so I believe I was somewhere over here. I don't know, but I guess you get the idea. If you have a solution, if you have basically a pair of linear equations, and if you have a solution, that's basically called consistent, otherwise it's inconsistent. Okay, now let's see if you have any other good examples over here. Okay, so I think it's enough for this part. We will, in the next video, we will talk a little bit about algebraic methods of solving a pair of linear equations. I'll see you in the next video. Thank you.